So welcome to UTC Canada. So this is the Cisco booth, and we have a very interesting demonstration that we've prepared here today for the conference, and we've actually partnered with two other companies, PowerTech Systems and Bits2 Systems. So in this particular demonstration, we have a little chart set up here. What we're showing is we have the CGR 1240. It's a full top router here that is for the IP mesh and DA systems. And we actually have this functioning in real time right now. It is connected to a DA gateway, a Cisco product called the IR500 router. And this is actually mounted over at the PowerTech booth and connected to a Capacitor Bank Controller. And it is actually running as a SCADA slave, and it's communicating over the RF mesh connected to this CGR router, over the mesh to the CGR, and then to SCADA Master that resides in a server that's sitting under this desk here.
Hi, Chris Bowman from PowerTech Labs, Smart Utility Department. And I'm here to show PowerTech's side of the UTC demonstration here in Calgary. And now in my lab, I'm going to walk you through the 4 pieces of equipment, and then I'll show you some of the data coming up on our screens. So we've got Cisco's new IR500 series router, bringing legacy distribution automation devices onto the mesh for potential new links for utilities. And so what I've done is I've used an advanced relay testing device called an Omicron 356 test unit, and I've actually coupled it to a Beckwith M6283A Capacitor Bank Controller, and I'm in control of the power system simulator in a sense, and injecting 3 phases of voltage and current to the Capacitor Bank Controller. And since I'm in control, I'm choosing to simulate a problem condition whereby the A-phase voltage is sagging outside of spec, and so this Capacitor Bank Controller is responding by alerting upstream through the link, which is being interpreted by the embedded troubleshooting application on the CGR. So the screens we're looking at here, this is a time series of the 3 phases of voltage. Here's the primary units. We're in the healthy condition right now. 25 kV is what I've programmed the system to be operating at. That would be the nominal feeder voltage. And then after a few moments, it's going to sag because of my program. There it is. So it's dipped down. We see the primary and the A phase is at about just under 20 kV outside of spec. And after a programmable timer, we've got a minimum voltage limit alarm. Okay, so a trouble condition. And then within the DNP3 protocol, you can optionally configure that to push what's called the unsolicited report by exception up through the link, which is what I'm sniffing here with a Wireshark. This is basically a remote into the head end application. This is the SCADA Master, which is pulling the slave through the link. And we see a reflection of this problem condition and its status indicators here.
In the demo that we have for this conference, we're working with Bits2. In the last few months, we've been able to port their IOX core system into the Linux operating system here. What it's doing is performing data analytics in real time between the SCADA slave and the SCADA master across the network. So when an event happens, for example, if the Capacitor Bank Controller was to have some problem or some issue, this would be seen by the analytics engine, the Bits2 analytics engine that's running here inside of the router, and it could create alerts. This is part of the concept of fog computing, where we're distributing compute right down to the edge, right onto the pole top.
So I'm going to describe our MIX core running on the CGR. What we're doing is analyzing the SCADA traffic that is going from a Cap Bank Controller through a Cisco DA gateway to a CGR. And inside the CGR, our application runs on the guest operating system side. And what it's doing is it looks at the SCADA traffic and analyzes the pattern and looks for anomalies in the pattern. A typical communication between a SCADA slave and a SCADA master is typically a request response. And when there's the Cap Bank Controller fires, there's an unsolicited response which generates a different traffic pattern. So our MIX core looks at the pattern and alerts the utility that something is going on and needs to be investigated. So it creates an alert. That alert is sent back to bit director running in the operations center. So what you see here is the flow packets being analyzed, and the upstream and downstream packets between the source and target devices are being analyzed and logged into the log file. And what happens is that when an alert fires, our application running in the data center, a grid director here would pick up the alert. In this case here, we've just created a sample alert here, but this is a CGR alert coming from the SCADA system, and it's caught here as a security alert. So what this does is gives the utility extra visibility, allow them to distribute their intelligence, not just in the operation center, but here it moves it closer to the field so that you have faster response times. It gives you additional alerting and visibility where the utility did not have that before.
Yeah, so a lot of moving parts, but it's been an exciting demonstration to develop with Gridstu and Cisco, and we're happy to show it at this year's UTC. Thank you.